So let's start question number 20. In this particular question, it says that if x1, x2, x3, x4, x5 are order statistics from uniform 0 to. First of all, it has said that parent population is x is following uniform 0 to. So that does mean that a small fx will be equal to, this small fx is the PDF of the parent population from which the sample has been selected, out of which the order statistics has been created. Obviously the sample size is 5 and so order statistics has been created. Now see here, fx is equal to 1 by 2 and obviously x will lies between 0 to, there is no issue. Now because there is a need of finding the small x1 like the minimum order statistics, their PDF and CDF, so in this case we need to find capital Fx as well. So for the capital Fx, all of you know that from 0 to x ft dt, which is 1 by 2 dt, and it will be x by 2. Got the point? So we have found a small fx and capital Fx here. Now see here, all of you know that if we try to find capital F x1x, got the point? So it has asked for not capital Fx1x, it has asked for a small fx1x. So obviously we will differentiate it with respect to x to get the small fx1x. So this is equal to, if you don't know, I will derive, but for that you need to comment. Got the point? If you are commenting, I will derive it as well, that how this particular formula came into existence. But see here, this is the value 1 minus capital Fx to the power n, if the sample size is n. Got the point? Where capital Fx is what? This one, that is the parent CDF. Clear? So CDF of the parent population. Now in this case, all of you know that this will become 1 minus x by 2, 1 minus x by 2 to the power n. But now see here, we have not to find the CDF, we have to find the PDF. So this I have done just for you. Now I am going to do it for the PDF. Got the point? Just to let you understand that this is also a one dimension, one extra dimension through which you can think. So because this is easy to do, that's why I have used here. Now see, I will differentiate it with respect to x to get the PDF, though without differentiating it can be found as well, but I am here differentiating. And so see here, d f 1x, whatever I have written, f x1x is it. So f x1x with respect to dx, but this does mean that d of 1 minus capital Fx to the power n, got the point, and dx, is it? But now I have to differentiate it. First of all, I will differentiate two things. I will differentiate 1. So once you differentiate 1, it will become 0. And then I will differentiate minus d 1 minus capital Fx to the power n with respect to dx, is it? Got my point? Now see here, once you differentiate it, it will be differentiated like this one. See, if I have to differentiate 1 minus x to the power n with respect to x, then what we do is, got my point? What we do is, we will write 1 minus x something like to the power n minus 1, and n should be before. But because here minus sign is there, that's why I put minus sign here as well. Got the point? This is the way. So at this time, what I am going to do here is, I am just writing here, this will be minus is before, then after I am going to do here d 1 minus capital Fx to the power n and d capital Fx, and then d capital, which is called quenching in the terms of physics or mathematics, you can say this. So this is either you can say product rule or quenching. I generally say quenching, but product rule is the formal name of it. So this is the formula I have applied. Now I have to apply this one in this, and then this is the small fx, you know already. So this is minus and minus here, so minus minus plus, it will become n and 1 minus capital Fx. Got the point? 1 minus capital Fx. Got the point? 1 minus capital Fx to the power n minus 1, and then this is the small fx. Got the point? In the same way as I have done here. Here it was x, then it was x. Here it was fx, then it is fx. There is no issue. So I have just written. Now I am just erasing this one so that you may not get confused. Now see. So we have got this, but now see, that means we have found that f x1 x, the value that we have got is n 1 minus capital Fx to the power n minus 1 and a small fx. Now capital Fx value we have already got, and a small fx value we know 1 by 2. So this becomes n by 2 in this case, and the value of n here is 5. x1, x2, x3, x4, x5 was there. So I am just putting all those values here. So this is 5 by 2 because fx is 1 by 2, and then 1 minus x by 2 because x by 2 was the capital Fx to the power 5 minus 1, that is 4. Got the point? So this value we got, but what they have asked is, they have asked fx1 1. So put the value of x equal to 1 in the expression. So just write it down here. This is fx1 1 is equal to, right here, 5 by 2 into 1 minus 1 by 2 to the power 4. Now this is equal to 5 into 1 by 2 into 1 by 2 to the power 4. That means 1 by 2 to the power 5 I can write. So I am just writing 1 by 2 to the power 5. Now 1 by 2 to the power 5 is 1 by 32. So this becomes 5 by 32. So this is actually 5 by 32 is the correct answer of this question. So if there is an option, that is D. Yes, there is an option. So 5 by 32 will be the correct answer for this question, and option D is the correct option.